Can there be life elsewhere in our solar system beyond Earth? Since the mid-20th century, scientists have been actively searching for signs of extraterrestrial life. This quest, one that has captured the human imagination for decades, now has researchers growing increasingly confident that Earth may not be the only place in the universe capable of supporting living organisms. It is well known that about 70% of our planet's surface is covered by water. Yet new findings suggest that Earth, in its distant past, may have been an even more water-rich world. Approximately 3 billion years ago, Earth could have been blanketed by oceans, with no emergent continents in sight. Over time, much of this water either evaporated or became locked away in polar ice caps. The implications of a once true ocean world are profound. Understanding these ancient conditions and how life originated here may help us predict where else life could arise, both within our solar system and beyond. Remarkably, every cell in your body is engaged in biochemical processes that echo the primitive chemistry that took place on Earth billions of years ago. Back then, our planet was a very different place. Its oceans were acidic and the atmosphere lacked oxygen. No plants existed to produce oxygen through photosynthesis. Yet these harsh conditions ultimately gave rise to life, and echoes of that ancient chemistry still play out within our own cells today. The ingredients necessary for life, key elements and accessible sources of energy, seem to be nearly ubiquitous. Indeed, our galaxy alone could harbor billions of Earth-like planets. With each new discovery and technological advance, we are only just beginning to explore the sheer scale of the universe. Although we have yet to detect clear, indisputable signs of life beyond Earth, many astrobiologists argue that given the vastness of the cosmos, extraterrestrial life is likely. Even so, it may be separated from us by millions of light years. Yet we need not look so far afield. There are intriguing places right here in our solar system that might provide the right conditions for life. Consider the logic. If life is inevitable wherever you have liquid water, volcanic activity, and a suitable chemical mix given enough time, then other cosmic locales might also host life. Or perhaps life is exceedingly rare, and Earth is unique. The only way to find out is to search. Titan, a methane-washed world. One such place is Titan, the largest moon of Saturn. Titan has a dense atmosphere, thicker than Earth's, and its chemical composition is reminiscent of our planet's early atmosphere. Blue skies and a nitrogen-rich air-cloaked Titan, but the temperatures there are frigid. The Huygens probe, which parachuted onto Titan's surface, found what appear to be riverbeds and lakes. However, these are not filled with water. Due to the intense cold, Titan's rivers and seas are composed of liquid methane. Methane on Earth is a gas used for cooking, but on Titan it forms lakes, rain, and even snow. Some scientists speculate about the possibility of methane-based life forms thriving in this alien environment. Titan also might harbor subsurface water, lending further complexity to the question of life's potential on this strange moon. Enceladus, the geyser moon. Enceladus, another of Saturn's moons, is much smaller than Titan, but no less intriguing. The Cassini spacecraft observed plumes of water vapor jetting out from cracks at Enceladus's south pole. This discovery strongly suggests the presence of liquid water beneath the surface, likely in a subsurface ocean. Could simple life forms, such as microbes, flourish in that hidden ocean? The finding of these geysers was a stunning revelation. They also feed Saturn's E-ring with fresh ice particles, and conditions deep below might resemble the hydrothermal vents found on Earth's ocean floors, known to be teeming with microbial life. In the coming decades, future missions will almost certainly return to Enceladus to probe its icy shell and the liquid ocean below. Europa, the hidden ocean. One of Jupiter's largest moons, Europa, may hold even more promise. Europa's smooth, icy surface hides a global ocean beneath a crust potentially 100 kilometers thick. This ocean contains more water than all of Earth's oceans combined. What's more, Europa is warmed by gravitational stresses caused by Jupiter's immense gravity, creating tidal heating that could drive hydrothermal vents on its ocean floor, conditions that on Earth support rich ecosystems. If life can thrive near Earth's hydrothermal vents, could it do the same on Europa? The challenge lies in penetrating the thick ice shell, an engineering feat that may be 30 or 40 years in the future. Nonetheless, the incentive is strong. Discovering life in Europa's hidden seas would be one of humanity's greatest achievements. Mars, a desert with a watery past. Closer to home, Mars has long intrigued scientists. We know that liquid water once flowed there, carving river valleys and filling ancient lakes. Today, Mars is a cold desert world with polar caps containing both carbon dioxide ice and water ice. The riddle of Mars's missing water, where did it go, and is some of it still there underground in liquid form, remains unsolved. The European Space Agency's ExoMars mission is focused on searching for signs of past or present Martian life. If microbes ever existed on Mars, they might have left chemical or fossil traces. With new technology, orbiters, and rovers, we are inching closer to resolving these questions. Additionally, recent studies have revealed large amounts of water in the Martian Grand Canyon system, significantly more than anticipated. We know that, billions of years ago, Mars was more habitable and contained abundant liquid water. Understanding what happened to that water could provide valuable insights into the conditions necessary for life. The implications of discovering life. Nearby. If future missions to Europa, Enceladus, Titan, or Mars uncover even the simplest forms of life, say microbial organisms, this would be a game changer. Proving that life arose independently in two places within the same star system would strongly suggest that life is not unique to Earth. Under the right conditions, liquid water, energy sources, and the proper chemical ingredients, life might be a common outcome throughout the universe. Of course, these prospects remain speculative. We have yet to find direct evidence of life beyond Earth. But the progress made in recent decades, mapping subsurface oceans on icy moons, discovering methane seas on Titan, tracing signs of ancient water on Mars, shows that the search for extraterrestrial life is both active and promising. What do you think? Is life lurking beneath Europa's ice, thriving near Enceladus's vents, or eking out an existence in the methane lakes of Titan? Could Martian microbes be slumbering in the planet's hidden reservoirs of water? Let us know your thoughts in the comments. Thanks for watching. If you enjoyed this exploration of extraterrestrial possibilities, please consider subscribing and ringing the notification bell. You'll never miss a new video as we continue to journey through the cosmos, seeking answers to some of humanity's oldest and most profound questions.